Welcome back. In the previous video, we used the Thermal Erosion Node to stabilize our ridges and peaks. At this point, our terrain already contains multiple layers of erosion, water-carved channels, sediment redistribution, and slope stabilization. The result is already quite realistic, but there's still something missing: wind. In real mountain landscapes, wind is a major shaping force. Some slopes are more exposed to prevailing winds, while others remain relatively sheltered. Over long periods of time, this creates asymmetry across the terrain. Certain areas experience more erosion, while others accumulate material and retain softer forms. It's this asymmetry that gives a landscape much of its unique character. Today, we'll add that missing layer using the Wind Erosion Node. And once the erosion pipeline is complete, we'll finish the process by adding a Heightmap Smooth Node. This final step helps clean up high-frequency surface noise that can sometimes be left behind by erosion simulations, resulting in a cleaner and more natural-looking terrain. I right-click in an empty area of the graph and type Wind into the search box. Wind erosion appears at the top of the list. I select it. Now let's connect it. I'm connecting the Heightmap output of the Thermal Erosion Node to the Heightmap input of the Wind Erosion Node. Then I connect the Heightmap output of the Wind Erosion Node to the rest of the pipeline that leads to the terrain. With the connections in place, let's click Generate and see the result. The generation is complete. Take a look at the terrain. There is a visible difference, but it's not quite producing the effect we're looking for yet. The reason is simple. Right now, the wind direction is still being applied as a fixed direction along the x-axis. It isn't yet taking the shape and orientation of the terrain into account. To create more believable results, we'll need to adjust the wind settings so the erosion interacts more naturally with the landscape itself. Once we do that, we'll start seeing the asymmetry and directional character that wind erosion is meant to create. Let's increase the wind strength value from 1.0 to 1.75. After generating, the effect becomes much easier to see. Material is being removed from the windward side of the terrain, while sediment tends to accumulate on the more sheltered slopes. This is exactly the kind of asymmetry we're looking for. It gives the terrain a genuine geographic identity, a landscape that appears to have been shaped by a prevailing wind direction over a long period of time. Let's explore the terrain from a few different angles. The valley floors, ridgelines, and slope transitions are now much easier to read. The overall structure of the landscape feels more coherent, and the terrain has gained a stronger sense of natural character and directionality. The terrain looks good, but when we zoom in, we can still see some high-frequency surface noise. These are small bumps and irregularities left behind by the erosion simulations. To clean this up, we'll add one final node to the end of the pipeline, the Heightmap Smooth Node. I right-click in the graph, type Smooth into the search box, and Heightmap Smooth appears right away. I select it. Now I connect it between the Wind Erosion Node and the Heightmap to Terrain Node. So the final pipeline becomes Heightmap, blend to hydraulic erosion, to thermal, erosion to wind, erosion to Heightmap, smooth to Heightmap to terrain. Let's look at the inspector. There are 3 parameters: radius, 3, iterations, 1, and strength, 1. These are reasonable default values for a subtle cleanup pass. Now let's click Generate. The terrain is noticeably cleaner now, but let's try something. I'm going to increase iterations from 1 to 5. Let's generate the terrain again. Take a look at the result. It's actually been smoothed a bit too much. Not only has the surface noise been removed, but some of the detail created by the erosion nodes has been lost as well. The ridge transitions have become overly soft, and the terrain is starting to lose some of its character. Let's undo that. I'll reduce iterations to 2 and generate again. This result feels much more balanced. The surface is cleaner, but the erosion features are still preserved. The channels, ridges, and terrain structure are all still clearly visible. That's exactly what we're looking for. The terrain feels refined without sacrificing the detail that gives it its natural appearance. This is the value we'll keep. So, what did we learn in this video? We added two important finishing touches to our terrain pipeline. First, we used the Wind Erosion Node to introduce wind-driven asymmetry and character, giving the landscape a stronger sense of direction and geographic identity. Then, we used the Heightmap Smooth Node to clean up the noise left behind by the various erosion simulations and bring the surface closer to a production-quality result. Together, these two nodes help transform the terrain from a collection of procedural shapes into a landscape that feels much more natural and believable. In the next video, we'll add the final piece of our erosion series, the Heightmap Edge Fade node. We'll use it to soften the edges of the terrain, eliminate the obvious box-shaped boundaries, and create the impression of a natural landmass, rather than a terrain constrained by a rectangular height map. See you in the next video.